Another type of discrete random variable is Poisson random variable. And it follows obviously Poisson distribution. Poisson distribution is a type of probability distribution that is often useful in describing the number of rare events that will occur during a specific period or in specific area or volume. And the examples of Poisson variables could be the number of traffic accidents per month at a busy intersection. So you see we've got a specific period, which is per month, and we can say that those events are rare because traffic accidents don't happen that often in comparison to some other events. Another example could be the number of death claims received per day by an insurance company. So in this case, the specific period is per day, and the variable that we're interested in is the number of death claims. And another example could be the number of diseased trees per square kilometers of a certain woodland. So in this case, we have a specific area, 1 square kilometer, and we are interested in the number of diseased trees, the probability that some certain number of diseased trees will be found within this certain woodland. Poisson random variable has its own characteristics. For example, the experiment consists of counting the number of times a certain event occurs during a given unit of time or in a given area or volume. The probability that an event occurs in a given unit of time, area, or volume is the same for all of the units. The number of events that occur in one unit of time, area, or volume is independent of the number that occur in other units. So the events are independent, similar to binomial, a random variable, and the mean or expected number of events in each unit is denoted by lambda. So let's have a look at the formula. So to calculate the probabilities that X number of events will happen within some period or some volume or some area, we take lambda, which is the mean number of events during a given unit of time, area, volume. We take it to the power of X, so the number of events we're interested in. Then we multiply it by E, taken to the power of negative X. So once again, the number of events we're interested in, and divided by X factorial. Similar to binomial random variable, this variable has also got its own mean value, which in this case will be just equal to lambda, and the variance is also equal to lambda. So let's have a look at the example. So suppose the number X of reported sightings per week of blue whales is recorded. So we are interested in the number of blue whales is seen. Assume that X has a Poisson probability distribution. Furthermore, assume that the average number of weekly sightings is 2.6. So historically, it has been estimated that the average number of seeing a blue whale per week is 2.6. And the task is to calculate the probability of seeing 4 whales in 1 week. So in this case, the number of successes, so the value of X is 4, and we know this from the very last sentence, probability of seeing 4 whales. And lambda, the mean value, so let's say the historical mean value, we also know it from this sentence. Furthermore, assume that the average number of weekly sightings is 2.6. So when we put everything into the formula, we get that the probability of seeing 4 whales in 1 week is 0.035 or 3.5%.